Here we go, quarter two. We've covered a lot of ground, so let's review everything for the quarter two final, which is you just got one shot, so make sure you come into it ready. So these are the types of problems that could show up on the final. Number one, graphing quadratics. So your instructions are to change it from standard form into vertex form. Vertex form is y equals ax minus h squared plus k. And right now it's standard form, which is just y equals ax squared plus bx plus c. So you can go from one to the other, and we're going to use completing the square. So completing the square is this: y equals x squared minus 8x. I'm going to scoot this 12 over here. Just set it aside for the moment, because what we want to do is we want to create a perfect square right there. That's your vertex form. It's got a perfect square. So I want a number right here that may or may not be 12. It's not going to be 12, but I want a number that is going to create a perfect square. The number I want is going to be dependent on whatever this is. So remember, you get the middle by addition, and you get the last by multiplication. So you look at b and you cut it in half. So negative 8, if I cut that in half, that comes from a negative 4 plus a negative 4, but a negative 4 times a negative 4. The number I want right here is a 16. So when it is a 16, that's a perfect square because I can factor it, and if I factor it, it's going to factor to x minus 4 and x minus 4, which is a perfect square. Anything times itself, so it's going to be x minus 4 squared. So 16 is the number I want. To figure that out, you cut the b in half and square it. Now, the very moment that you add 16, you must take it right away. Plus 16 minus 16, so it's like you added 0 to the equation, which does not change it. So I'm going to play with these three together, and that gives me my x minus 4 squared. These two I play together, that gives me minus 4. Now it's in vertex form. Vertex form is easy to find the vertex. So this number that I add or subtract in the parentheses before I square is my horizontal. This tells me go left or right. And because it's a minus 4, that's telling me to go actually to the right 4. So I'm going to go 1, 2, 3, 4 to the right. And then this negative 4 is my vertical shift up or down, and that is down 4, 1, 2, 3. So my vertex is right there. My vertex is at the point over 4, negative 4. So to graph it, I just need one more point. So I'm going to test the dot close to my vertex. I'm going to test going over 5. And if you know what the x is but you want to find the y, you just plug that into your model. So I'm going to take 5 and I'm going to plug it in right here. 5 take away 4, that's 1. Then you square it. 1 squared is 1. So I got 1 minus 4, that's a minus 3. So I'm going to go over 5 and down 3. And then my dot for free reflects across the vertex. There is my parabola. Okay, the domain and the range. The domain is the left and right. That's my x number line. So if this parabola goes forever, what I'm asking you is on the x number line, how far, what is the very farthest left this parabola is going to go? And what is the very farthest right this parabola is going to go? And it looks like it's going to go from a negative infinity all the way to positive infinity. So the domain is all real numbers. It's going to cover every number on the number line. My range, the range is how far up and down. Okay, how far up? This is going to keep going up and up and up forever, but it never ever goes lower than right here. So it's going to increase forever, but it never goes lower than negative 4. So my range is going to be a negative 4, including, so it's got to be bracket, all the way to positive infinity, and everything in between. Okay, they give you standard form. They want you to change it to factored form. Let's factor this. factor. So I'm looking for, if I use this little template, it's got to times and give me a negative 18, but it's got to add and give me a negative 3. What multiplies gives you negative 18, adds gives you negative 3. I think a 6 and a 3 is going to be 18, and I want the 6 to be negative. Negative 6 times 3 is negative 18. Negative 6 plus 3 is negative 3. So there we go. So I'm going to change this from standard form to x minus 6 and x plus 3. Okay, now once it is in factored form, it's pretty easy to plot the roots. Okay, your roots are your x-intercepts. It's where your parabola is going to cross this x-axis. So your roots are going to happen on this x number line. You're not going to go up or down on the y. So your y is going to be 0. So that's nice, because if I want y to be 0, and I'm asking what values I can plug in for x that really will make y be a 0, this right here is a multiplication problem. And the only way you can times and get your answer to be 0 is if you times by 0. So now you ask, what would make this 0? What number can I plug in for x? And then I got a minus 6, and I want to end up at 0. And it is a 6. If I plug a 6 in, 6 then take away 6 is 0, times that's going to be 0. What number can I plug in for x and then turn around and add 3 and end up at 0? And that is a minus 3. So there are my two roots right there. So now I'm going to plot those two roots. 6 and 0 is a dot right here. Minus 3 and 0 is a dot right there. Okay, now I just need to find the vertex. The vertex I know is going to be halfway between. It's going to be the midpoint of those two. So if I find the average of these two dots, if I take 6 and negative 3 and I add them together, that gives me 3, and cut that in half, that will give me the average. The average is exactly at 1.5. So I'm going to come over at 1.5, and that is my line of symmetry. 1.5, I know it's on that line, I just don't know where on that line. So if I know the x is 1.5, but I do not know the y, I take 1.5 and I just plug it into the model, either to the original one or to the factored one. I do the math and it will tell me what the y is. So I'm going to take 1.5 and I'm going to plug it in there and there. And this is just, I'm going to do my calculator. So parentheses 1.5 minus 6 times 1.5 plus 3. And it gives me, after I do the math, it gives me a negative 20.25. And if you want to double check, if you think that might be a little too big or something, plug it into this one. And if you get the same answer, then you know 100% you're right. So I'm just going to go with this, I'm right. So I'm going to go over to this 1.5, down 20.25, which is off the graph. And my parabola is going to look like that. Okay, the domain and the range. The domain is the same. If this parabola keeps going forever left and right, it's going to cover every number on the number line. So my domain is all real numbers. My range, how far up and down, this is going to go all the way to positive infinity, but it is not. The smallest it goes is negative 20.25, and it includes it, so that's why I got a bracket. All the way to infinity, and you cannot include infinity because it's elusive. You can never catch it, so it's parentheses. Okay, the third way to graph is just leave it in standard form and graph it. So in standard form, the perks in standard form are the y-intercept. The y-intercept is c. Y equals ax squared plus bx plus c. C is your y-intercept. So I'm going to come up on 3, put a dot. Okay, now I'm going to find my vertex. So first I got to find my line of symmetry. My line of symmetry is a negative b divided by 2a. So it is going to be a negative negative 4 divided by 2 times negative 2. It's going to be a positive 4 divided by a negative 4. It's going to be a negative 1. So negative 1 is my line of symmetry. that means this dot flips over here for free. And you're going to use the same thing over and over and over and over and over again. If you know that your vertex is going to be -1 for the x and you want to find the y, you just take -1 and you plug it in for x and do the math. But you've got to put it in parentheses or else that's going to mess you up. So where these x's are, I'm just taking the x's and putting them in parentheses, and in place I'm putting a -1. So -1 squared is 1. 1 times -2 is -2. -4 times -1 is +4. And then plus 3. And then do that. 7 minus 2 is at 5. So I'm going to go over 1 to the left, up 5. And that makes sense because I know it should be concave down because this is negative. If my a is negative, I know it's going to be flipped upside down. Okay, the domain and range. The domain, again, is all real numbers. The range, this time, the smallest it's going to be is -infinity. So if I go smallest to largest, the largest it's going to be is 5. It does not go any higher than 5. But it includes 5. So kind of your domain and range always goes smallest to largest. Okay. Can you identify the vertex by looking at a table? So here's what you know about a vertex. It is the point where it turns around. It is, if you're looking at a picture, it's easy because it's the dead center. And it is the moment where everything turns around and starts to go the other way. So if you're looking at a table, I think I found it right here. Because look, everything above it and below it are reflected. So 1 above it, 1 below it. 10 is above it, 10's below it. 2 times above it, 2 times below it. 25 is 3 times above it, 3 times below it. But if you can't see it, then just draw yourself a picture. And this is a free problem. There's no way you should miss this. So if I go 0 down 2, over 1, up 1, over 1, up 1. So if you just plot these points, it'll give you an idea. It'll give you a picture. So I know the vertex is right there. 0, -2. Axis of symmetry. So if I keep going, if I go over 2, up 10. So my axis of symmetry is this right here. And my axis of symmetry is x equals 0. So it's right, it goes right through 0. That's the dead center. Okay, the number of x-intercepts. How many x-intercepts does this have? Looks like it has, how many x-intercepts? If I connect all these dots, it's got 2 x-intercepts. So the vertex, is it a maximum or is it a minimum? And it is a minimum because it is the lowest point of that parabola. The maximum will be the highest point. Okay, 7. Now I'm going to give you some pictures and you give me the functions. So what model are you going to choose? I'm not going to choose the vertex because look, my vertex is on fractions. My vertex is somewhere between a -5 and a, well, 1, 2, 3, 4, 5, -6 and a -7. I don't know where it is. And it's somewhere between a -1 and a -2. Maybe it's like -1.5. I don't know. But I do know exactly where the roots are. Okay, my roots are at 1 and 0 and -4 and 0. So if I know exactly where the roots are, I'm going to use the factored form. So the factored form is y equals a, x plus or minus a root times x plus or minus a root. Okay, I'm going to start plugging stuff in. Y equals, I don't know a, but I do know the roots. Okay, now the roots are a little tricky. This is actually going to be a -1, and this is actually going to be a +4. So your roots, where they are on the graph, are actually opposite when you plug them into the equation, because look right here. This 1, 0, if I plug 1 in for x, it has to give me 0 for an answer. So let's take 1 plug it in for x, and if I plug 1 in for x, I must minus 1, because 1 take away 1 is 0. There's my 0. And if I take negative 4 and I plug it in, it's got to be a negative 4 plus 4. That's how I get my 0. So your roots are kind of actually opposites in the table to the equation. They're opposite. Okay, now the only thing you got to find is a. What a does to this parabola is flips it right side up, flips it upside down, and it accelerates it. So if you're going to times it, it's going to make it skinnier. If you divide, it's going to make it wider. So a is a dilation. And to find a, you need to choose a point on your graph. So if I choose, I got 2 points right down here. I'm going to choose this one. I'm going to choose this point. How do I get to that point? That point is 0, negative 4. So I'm going to take 0 and I'm going to substitute it in for the x's, and I'm going to take negative 4 and I'm going to plug it in for y. So negative 4 equals a 0 minus 1, 0 minus 1 times 0 plus 4. So negative 4 equals a times a negative 1 times 4. So negative 4 equals negative 4 times a. Divide by negative 4, divide by negative 4. A is actually 1. So my final answer, don't even need to write the 1. X minus 1 times x plus 4. Okay, this one now, you do know exactly where the vertex is, but you do not know where the roots are. The roots now are on fractions. So you're not going to use the factored model. You're going to use the vertex model. The vertex model is y equals a x minus h squared plus k. So your vertex is going to be right here. Your vertex is left 1. Up 3, and your vertex is your h and your k. So if I start plugging into my model, I'm going to go y equals a x minus whatever h is. My h is a minus 1 squared plus whatever k is 3, and this should be a plus 1. So you got to remember, the number in the parentheses moves you left or right. If it's plus 1, that moves you to the left. If it's minus 1, it moves you to the right. So make sure your sign in here is correct. Okay, now my a, to find a, is the same way we did on the factored form. If I take this dot right here, which is 0 and 1, okay, this is just an x and this is just some y. So I'm going to take this 0 and plug it in for x. I'm going to take this 1, plug it in for y. 1 equals a times 0 plus 1 squared plus 3. And now I'll do the math and it'll give me a. So 1 plus 0, 1 squared is 1. So I got 1 equals a times 1 plus 3. Do not combine these two numbers right here. This 1 is being multiplied to the a. So it's just 1 equals 1a plus 3. So now you've got to ditch the 3. Minus 3, minus 3. A should be equal to a negative 2. So your final answer is going to be y equals negative 2. X plus 1 squared plus 3. There you go. Okay, this next one, A, B, C, D, which of these could be that graph? So let's look at them. I know this graph is concave down, so I know A has to be negative. So I'm looking right here, and I'm liking C and D, so I'm going to eliminate A and B because they are positive. So now between C and D, let's look at C. The number right here tells me to go left or right. This tells me to go right 5 and down 3, and that's my vertex. Right 5, down 3. My vertex should be somewhere like right there. So C is gone. This one tells me go left 5, up 3, left 5, up. Okay, that's it. Easy. Okay, now this is material we've covered the past 3 weeks or so.
Hey guys, this is Brian Sound here. It's a little shout out from Delta High School to you.
Good man, Branson. That was a little treat for you guys. Branson stopped in. So, where were we? Now back to the tables. Okay. Geometric and arithmetic sequences. On the left, you have a geometric sequence. Geometric, they're exponential. They grow by multiplication. So 2 to 8, that was times 4. So this is going to be times 4. So that's going to be 32 times 4. Let me get a calculator. Is that 128? 128 times 4 is going to be 512. So those are not too bad. But now the ones in between is actually going to be times 2. So this is going to be 4 times 2. That's going to be 8 times 2. That's going to be 16 times 2. So really every single time we're just timesing by 2. So this one's not too bad. Okay, let's look at the other one. This one's arithmetic, so it's growing by addition. 2 to 8. That went up 6. So that means it's going to go up 6 every other time. So that's going to be a 14. That's going to be a 20. That's going to be a 26. But in between, it's going to go up 3, up 3. That's going to be 5, 11, 17, 23, 29. So here is the idea. If you are growing by 6 every other time and you want to break that in half, because you're growing by addition, you must use addition. And the question is, what number add itself is going to give you 6? And it's going to be 3 plus 3. So what you're doing, if you want to break addition in half, you just divide it by 2. 6 divided by 2 is 3. That's how we got the 3. But this is not the same if it's grown by multiplication. If I'm asking you, I'm growing by times 4, and I'm asking you this question: what number times itself is 4? And it is not 4 divided by 2. You don't cut it in half like you did on the addition. You actually do square root. So it's going to be the square root of 4 times the square root of 4 is going to give me 4. Which the square root of 4 is 2, and 4 divided by 2 is 2. So they're the same, but that's just a coincidence. That does not work every single time. It is always going to be square root. It is never going to be divide. You're only going to divide if it's growing by addition. If it's growing by multiplication, the only way to cut multiplication in half is a square root. Okay, now, God, we're going to run out of time. Let's write the functions real quick. And then let's look at this next one. So, the function, this function right here, is the one I'm worried about. An exponential function, because it's growing by 2 times 2 times 2 times 2 times 2. My exponential model is y equals a times b to the x. Okay, b is pretty slick to find. B is going to be my 2. That's your multiplier. That's your base. That's what you're times by over and over. So that's going to be my b. So it's going to be 2 to the x. Now, if I let's test this out to find a. A is usually going to be the mate of 0. So if I go backwards, this should be 1. So I'm guessing a is going to be 1 and b is going to be 2. So it's a piece of cake. Let's test it though. Let's test it for 3 gives you 8. So y equals 2 to the 3. Does that really give you 8? 2 times 2 times 2. Yes. Let's test it for 2. Y equals 2 to the 2. I'm plugging these numbers in for x. These are my x's. Okay, we're in pretty good shape. The linear model. Let's review one real quick. So we are growing every time by plus 3, plus 3. Now my linear model is y equals mx plus b. That is 3. That's your growth. So my rule is going to be times by 3. So I'm going to take this 3 and turn it into an 8. I'm going to take 3 and times it by 3. That is a 9. And I want to get to an 8, so I'm going to minus 1. 9 minus 1 is 8. So my rule, I think, is times by 3, then minus 1. What is 5 times 3? 15 minus 1. Okay, that's it. So my rule is y equals times by 3 minus 1. Or your b is going to be also the mate of 0, which is going to be a minus 1. Okay.